Hello everyone, this is the first lesson recording for IM1 for September 15th, 2020. To begin, if you have access to a printer, please print out these two documents, and they are available on Canvas under resources, as well as this is the review packet, and that's under the homework. Also, have your last two homework out. That's the one on function evaluation and domain and range. And as a warm-up, you are going to start on the first card of the Desmos. So a lot to do in the beginning, okay? If you are watching for the first time, then you're going to go to student.desmos.com and join with the class code here. Great. So this is the first document I asked you to print out. Okay, so this is the function notation and domain and range notes that I felt that it would be helpful for you to have concrete in front of you to prepare for the test that's coming up on Friday. So you have two choices. If you have printer, you can print it out, and that will certainly be nice. Or you can access it through just looking through it as a Google Doc because you have the link, or you can copy down the notes into your notebook. It's up to you. But let's go through it more thoroughly. So the first part, it says, is function notation. What is the function notation and how do I use it? If you have g of x is x plus 1, this is an example of a function notation. First of all, what are the different parts? G is the name of the function. And how do I read this function? You say g of x is equal to x plus 1, or g of x is equal to x plus 1. That's how you would read it, where x is the input and g of x together is the output. Okay, and you can use this notation to evaluate the function, such as if I have g of 4, what does that mean? The input, the x value, is 4. So you are plugging in 4 anytime that you see an x, and you're looking for what is the output when you put in the input of 4. So you plug in 4 whenever you see an x, and you get 4 plus 1 is equal to 5. So the output is 5 when input is 4. That's what it tells you. Next, what must be true about a function? For it to be a function, you need to be asking this question. For a specific input, do I always have the same output? Is the output predictable for each input? If the answer is yes to both questions, then it is a function. So let's look at this table of data as an example. Look at this. So in this, is this a function or not a function? This is a function. Why? Because when you put in x as 7 as an input, you got 6. When you put in negative 2 as an input, you got negative 3. When you put in 0 as an input, you got 4, and so on. Okay, that was your input and output. That's what happened. Okay, now did each of the input always give a specific output? Okay, so when you put in 7, did it always produce 6? Well, there's no other input of 7 here. So yeah, that's the only output that we got. Negative 2, do I have any more input of negative 2 here? No, I do not. And do I need to be asking myself, are there any repeating input? Okay, if there's no repeating input, then output is always going, it doesn't really matter. It's just going to be different. Okay, whether it's same number or always, if there's no repeating input, then this is a function. So because output is predictable for that given input. So if I was to put in 7 again next time, I know it's going to give me 6. If I put in 0 as an input, I know it's going to give 4. It's not going to be 4 or something else. All right, I'm going to give you another example. What about this one? For a specific input, do I always have the same output? Or is the output predictable for each input? Look at this table, okay? In contrast, let's see. Look at the input. Are there any repeating inputs here? the only repeating one is 2 and 2 here. Okay, so that means when you put in 2, you got 9 as an output. But when you put in 2 again, this time you got -8. So for the same input, sometimes you got 9, sometimes you got -8. So then is the output predictable? No, it's not, is it? Okay, so this is no longer a function because the input of x is equal to 2. You can sometimes get 9 as the output or -8. So the output is not predictable, so it is not a function. Okay, so then we went on to domain and range. Okay, so what is the domain of a function? Domain is simply just the set of all possible x values, or instead of x, we can think of it as input value. Because remember, x is the input, output is the y-axis. That's what we got from the graphing stories and many other exercises that we did. And we need to look at the minimum of x to the maximum of x. So to do that, I can draw a line to see where do I have the boundaries. Okay, remember the Desmos exercise we did? We moved those bars to just cover up the graph, right? And so this is the x-axis. That means we have the graph extending from -4 to +4. So that's what we have in this example. Oops. Okay. And so example has the domain of -4 to 4. What about range? What is range? Range is just simply the set of possible y values. So instead of just looking at the x values, now we're looking at the y values. How far does the graph extend on the y-axis? Okay, so we have to go from the minimum y to the maximum y. So if I was to use my pen and draw here, it extends from, oops. Okay, that's the maximum y that we have, and then we have, this is the minimum y. So it extends from -3 here to +4, right? So then we can say that this is the domain, or the range is, this example is -3 to 4. Okay, that's in words. Let's look at another example. Again, domain is all possible input values in words. So how do I do this? Probably the easiest way is to draw how far does the graph extend. Okay, on the x-axis, it extends from here. Okay, and then the maximum x is down here. Okay, now what about the y-axis? So let me choose a different color, and for the y-axis, it extends from here. Oops, let me get another color. Okay, and then to here. Okay, so this is the extent of the graph. This is just like using the Desmos bar, but now we are creating a rectangle to completely enclose the graph. Okay, if I click on this, then it's gonna all go away. So I'm sorry. So all possible input values. So what does that mean? We have x values that are between -2 here. We said it was -2 was how far the rectangle extended to, all the way to +4. Okay, what about the y value? Extended from the minimum y value was -3, and the maximum y value was +5, right, from this graph. So it extended from -3 to +5. Now, how do I represent this as an inequality? remember the smaller number goes to the left, just like you see it on the number line. Number line, you know, -2 is on the left of +4, right? Just like that, you would represent it as -2 on the left hand side, +4 on the right hand side. We're talking about domain, that means we need the x in the middle, okay? And the inequality has to be opening to the right. That means it's alligator mouth. If you picture this as an alligator mouth, it's opening to the right. It wants to eat up x. And in this case, it wants to eat up 4. Why? Because this is the bigger number. X is bigger than -2, and 4 is bigger than x. So what we're really saying is x is between -2 and +4, and it includes those two values as well. Okay? And that's being represented as the closed circle. Closed circle means that those -2 and 4 are included as the value, okay, acceptable value. And then let's see, for the output, it extended from -3 to +5. So -3 to +5, again, -3 is the smaller number is on the left, and then +5 is on the right. And this time, oh, there's a mistake here. This should not be x. This should be a y. It's a typo. I'm sorry. I will fix this on for the lesson. And again, the inequality sign should be opening to the right. Okay? All right. So then let's do some practice here. What is the domain and what is range? Well, to do this, let's draw some rectangles. Oops. I am going to remove everything. And let's draw some rectangles, and I'm going to do it in blue. Okay, so how far does the x-axis, how far does it extend on the axis? I am going to draw some line here. Okay. What about the y-axis? So let's do it in green. Okay, the y-axis, the maximum is right here. And the minimum seems to be a little bit below. Oops, a little bit below. Okay, so actually let me redo that because it didn't quite cover. Okay, it's a little bit below 3. Okay, it's a little bit below 3 and 0. Okay, so let's talk for domain. Let's just talk about the domain first. Domain extends from domain extends from -2 to +2, right? So domain extends from all real numbers, all real numbers between what? -2 and +2, right? So how do I represent this? Again, the smaller number on the left, -2 like this, and then bigger number on the right. And we're dealing with domain, so we need the x in the middle. Oops. Okay, and the inequality sign is always going to be opening to the right. Like so. Okay? Alright, then what about range? We said the range extended from let's say this number is, let's say, so all real number between what are the two numbers? So this would, I would say, -3.2 and to 0. Okay, so how do I represent this? So it will be -3.2, and the bigger number is 0. We're dealing with the range, so we need to write y, not x. The alligator mouth is going to be opening to the right. Okay, so that will be the range. Okay, next up we are going to look over our homework, so please get that out, and we will go continue in our next lesson recording.